Hello class, just wanted to show you another example of solving two-step equations. So like I said in the last video, you are going to undo the math on the side of the variable to isolate the variable, to get the variable by itself. And when you do this, you're going to follow the reverse order of operations. So you do the opposite of what you would do when you're normally trying to perform mathematics. So here's an example, x minus 2 all divided by 3 equals 7. When I'm trying to solve this equation, when you think about order of operations, the last thing that you normally do is add subtract. So you would think to work in reverse, you'd have to add 2 in the situation. But that's actually not the case. If I take just a quick look at this problem, if I tried to just stick a number in here and I did this math forward, the normal way that we would do it, would you divide by 3 first in the situation? No, you wouldn't. What you would do is you would take 4 minus 2 first, which is 2, and then you would divide by 3. And obviously that's a repeating decimal, 0.6. Okay. So what that means for this situation is when you're undoing the math, you are not going to add 2 first. That would actually mess your problem up a little bit. So what we have to do is we're going to undo the math, and in this situation, the first thing that we're going to undo is actually the divide by 3. So to get rid of the divide by 3, we need to multiply by 3. And if I have a times 3 and a divide by 3, 3 divided by 3 cancels out to 1, which essentially eliminates it. Just like anything else, any other equation that we're trying to solve, what you do to one side, you have to do the other. So if I multiply by 3 on the left side, I have to multiply by 3 on the right side. And now my new equation is going to be x minus 2 equals 21. Okay, so we simplified it a little bit. We made it a little bit easier to deal with. And now a lot of you are shouting out the answer. You can go ahead and pause the video and solve it yourself, or you can just wait for me to do it. X minus 2 equals 21. We will add 2 to the left side. What we do to one side, we must do to the other. So add 2, minus 2 plus 2, that cancels out. Leave me with x equals 23. And we can check our answer. You plug in the 23, and it ends up working just fine. So here's another example, 4x plus 7 equals 23. We're going to try to solve this equation. And some of you might be a little confused. Well, one problem, we got rid of the addition first. One problem, we got rid of the multiply first. And it can be confusing, especially when you're trying to think in reverse order of operations. You're kind of going through PEMDAS, and then I got to go SA, and it can be confusing. So a neat little trick that you can remember when you're solving equations is to always pick on the lonely number. So when we're trying to solve an equation, we're trying to get the variable by itself. So for right now, I'm just going to kind of block this out. I don't really even need to worry about the 23. I'm worried about getting x by itself. So I'm looking on the left side of this equation. The 23 didn't really go anywhere, but I just don't want you to look at the 23 for right now because we're only dealing with the 4x plus 7. So when I'm trying to solve this equation, I'm trying to get x by itself. And if you look at it, there is a number that's kind of lonely. I'd like you to pause the video and point at that number. Good. The 7, it's lonely. The 4 is together with the x, they're hanging out. The 7, all by itself. When you are solving equations, you can be a bully. You want to pick on the lonely number. So if I have a plus 7 here, I'm going to subtract 7. Pick on it. Now, what we do to one side, we do to the other. So if I put that 23 back in here, because like I said, it didn't go anywhere, what we have to do is subtract 7 to this side. Now, if you follow this rule, pick on the lonely number, it will always show you the right way to solve the problem. So 4x equals 16, and then we divide by 4 on both sides, and x equals 4. Okay, so here we go. Back to that weird looking problem that we had to begin the last video with. And if we think about this, okay, again, we're trying to isolate the variable. We want to get x by itself to solve it. So I'm going to work in reverse order of operations, which can be confusing. Now, when you look at this problem a little bit differently, you say, well, let's pick on the lonely number. The lonely number in this situation, if you point to it, is, yes, 2. 2 is the lonely number. X plus 10, they're hanging out together. 2's all by itself. So I need to actually get rid of that 2 first. And to get rid of a divide by 2, I have to multiply by 2. Okay, so there's step 1, all done. So we have x plus 10 left over here. And on the other side, what you do to one side, you have to do to the other. We have 26. All right, now it's just a simple one-step equation. Subtract 10 on both sides, and you have your answer. So x equals 16. And you can check that out by plugging it in and making sure that it works out to 13. So pick on the lonely number, and you will always go in the right order when you're solving equations.